giant covalent structures, C60, fullerene, and graphene. All of these represent other structures where you can find covalent bonding. Giant covalent structures are made up of a large number of atoms which are bonded together via covalent bond. Diamond is one of the examples of giant covalent structure where it's made up of a network of carbon atoms where each carbon atom forms four other covalent bonds with four different carbon atoms. Because there is no free electrons or ions within the structure of diamond, diamond does not conduct electricity. And because of the nature of the covalent bond, the only type of bond that you find is the covalent bond. Covalent bond is a very strong bond that needs a high amount of energy to break these bonds. So diamond has a very high melting points. And it's also very hard because the atoms are held in a very rigid lattice structure, so they are used in cutting tools. The second example of the giant covalent structure is graphite. Graphite is made up of layers of hexagons of carbon atoms, and each carbon atoms will only form three covalent bonds with three other carbon atoms. The carbon atoms within each sheet will form a strong covalent bonding, so graphite has high melting points because they need high energy to break these covalent bonds. However, the sheets are bonded together via weak bonds, so the layers or the sheets can easily slide past each other, so graphite is soft and slippery and can be used as lubricant. Because each carbon atom only form three covalent bonds, they only share three electrons out of the four electrons in the outer shell. There is one free electron that can be localized for each carbon atom within the structure. And these electrons can easily move between the layers or between the sheets. So graphite can conduct electricity, and it's usually very useful in making electrodes. C60 fullerene is another structure which is not a giant structure. C60 fullerene is a large covalent molecule. It's made up of only carbon atoms, and the number of carbon atoms within each molecule is 60 carbon atoms. Each carbon atom here will form three covalent bonding with three other carbon atoms. That means there will be one free electron or one delocalized electron. However, this delocalized electron cannot move between the different molecules, so the fullerene does not conduct electricity or is a poor conductor of electricity. The different molecules are held together by weak intermolecular forces in the same way as the graphite, and they can slide past each other, so C60 fullerene is soft. And as we said, it's a poor conductor of electricity. Graphene is formed from graphite. It's only one sheet of carbon atoms, these hexagons of carbons, these hexagon structures, where each carbon atom will form three other bonds with three other carbon atoms. It's a 2D structure and it's very thin and light. The type of bond between the different carbon atoms is covalent bonding, so they have high melting point. They also very thin and light because they only formed of one sheet of carbon atoms or one sheet of these hexagonal structures. Um, they can conduct electricity because in the same way as graphite, they have only three covalent bonding and they have one delocalized electron that can be moving, and so graphene can conduct electricity.